Question 32 is asking us to add and subtract polynomials, and so when we add, obviously there's a plus sign here. So what I would end up doing on a problem like that is I would just rewrite the problem with this expression here underneath the ones I can combine with the first expression. So the 2x squared plus the 4x minus the 8. Just rewrote them. And this way I've got everything lined up, so I can just add them together. And when you add, you just change the coefficient. Exponents stayed the same. So 2x squared and the 3x squared make 5x squared. Positive 6x is what you get when you add 2x and 4x. And here we have to add because they're the same sign again, but it's negative 12. And that is our answer. So when you see the subtraction problem, change it to addition. When you do that, all of the signs are going to end up changing. So make sure you change them all there. And then just take the terms and write them underneath. So I'm going to just take these terms and write them underneath these other ones here. So the 4x squared goes there, the negative 2 goes there. Add that stuff up because now we've changed it to an addition problem. If they're opposite signs, you subtract, like we do with the x squared terms. Here we just don't combine anything with that 4x. And we got a negative 10. I have to add because they were the same sign. Here it says the sum of two binomials is this. So this is what it equals. One binomial is this. So we want to find the other. So basically what we need to do is we need to take the sum here, 5x squared minus 8x, and we are going to take this 2x squared plus 3x away from it. And so basically I'm subtracting this expression from this one. Now when I do that, again, just as I did on letter B there, I'm going to end up adding the opposites. I'm going to switch those signs there. And so when I do that, I now will take these terms and write them underneath and combine. So I got a negative 2x squared, and I got a negative 3x. And so when I combine that, I end up with a 3x squared. I have to subtract there. And here I have to add because they're the same sign. So I end up with an 11x. And so that would be the other binomial that would add to 2x squared plus 3x to equal 5x squared minus 8x. Here we want to factor out common factors. So look at them, they're all even. Take out a 2x. And so put that on the outside, do some division, see what's left over. You got an x squared minus 2x minus 15. And this will factor one more time. It's just a trinomial that would factor as two binomials. It'll make an x minus 5 and an x plus 3. And always check those outside terms and inside terms just to make sure you got the signs right especially. So here no common factors, so we just factor it. And I see it factors down to an x minus 7 and an x plus 5. Opposite signs, because they multiply to make a negative 35, they subtract to make negative 2. And that's what negative 7 and 5 do. Here I have a plus sign, so I knew I had to have the same sign. But it's going to end up being a minus sign inside the binomials because they have to add to make a negative 7x. And that's what those do. Here we have a y squared at the end. So just write it as x plus 3y. And it's another x plus 3y. So it's quantity being squared. If you notice that the x and x make the x squared, and we have 3y and 3y make 9y squared. The x and 3y make a 3xy, and another 3xy add to make 6xy. So you could end up seeing the answer like this. X plus 3y quantity squared. Well, this next one's just a trinomial, a little bit tougher because of the 3 out in front of the x squared. We'll just write down 3x and x, make 3x squared. Note that both signs are positive because they multiply to make a positive and add to make a positive. So I'm just thinking of how to get 15. I'm thinking of 5 and 3 in this form because you see how 3x and 5 make 15x, and this makes 3x, and those will add to make 18x. So it does end up matching. That is our answer. Well, here we want to solve the quadratic polynomial. Now, they don't specify the method, so we can use any method. And when I do solve, typically I'm going to try to factor. I think that's the easier way. Quadratic formula is fine too, but sometimes the numbers get really big and it can be difficult. So 2x squared plus 5x minus 12 all equals 0. So I'm going to try to factor, see if that works. And I see 2x and x make 2x squared, numbers that multiply to make 12, but the outside and inside terms subtract to make 5. Well, if I put maybe like a 4 here and a 3 here, you see I can get those to subtract to make the 5. See, 2x and 4 make 8, minus 3 makes 5. And if I want to make it a positive 5, I'm going to make the 4 positive to make an 8x and the 3 negative to make negative 3. And that does end up working out. So when I solve this, remember you're taking the factors and setting them each equal to 0. And then you're just doing opposite operations to solve. So here we'd end up with 3 over 2, because we had to add the 3 and divide by 2. Here we end up with negative 4. And so those are the two answers. So again, that's what I'm going to work on. I'm just going to end up adding this 10 to both sides, and it's tough completing the square. Quadratic formula gives you big numbers, so just try to factor. That would probably be the best way to do it. And I go ahead and substitute those numbers. Actually, I'm going to just go ahead and factor. This is 3x and x to make 3x squared. I know both signs are positive because they multiply to make a positive and add to make a positive. And I'm going to put a 2 here and a 5 here. And this works because 3 and 2 make 6. 5 and x make 5x, 6 and 5 make 11. And then just set those factors equal to 0. And so when you do that, you end up with 2 answers. You get negative 5/3 for this one because you have to subtract the 5 divided by 3. Here you have to subtract the 2, and so that's how you get negative 2. Well, this next one, again, same sort of thing. Subtract the 21, always set it equal to 0 if you can, and then we go 2x squared minus x minus 21, all equals 0. So again, I'm going to try factoring, and I get 2x and x to make 2x squared. Numbers that multiply to make 21, well, if you put a 3 here and a 7 here, those multiply to make 21. Check the outside terms. That makes 6, and this makes 7. Those will subtract to make negative 1 if you make the 7 negative and the 6 positive. Well, just set the factors equal to 0 and come up with those answers. So you get 2 of them. Here we have to add the 7, so we get positive 7, then divide by 2, so 7 over 2. Here we just have to subtract the 3, we get negative 3, and that is our answer. Same thing over here, subtract the 2 from all sides. We've got this 3x squared minus a 5x minus a 2 all equals 0. So I'm going to go ahead and factor that. I know it's 3x and x make 3x squared. To get the 2, it's going to be a 2 and a 1. And I have to go in this order because this will make 6 and 1, which was subtract to make 5. Now to make it a negative 5, just make the 2 negative and the 1 positive. So set those factors equal to 0 and come up with those two answers. So here we have to subtract the 1, so negative 1. Divide by 3, you get negative 1/3. Over here, just add the 2. That's how we get 2. Well, last one of that type. Here we have to subtract the 4 from all sides. And when I do that, I've got this 7x squared, a plus 27x, and we get a negative 4, all equals 0. So I'm going to start off with two factors. Start with the 7x and the x to multiply to make the 7x squared. And to multiply to make 4, I'm going to put the 4 here and a 1 here. You see, those will multiply. 7 times 4 makes 28. Make that a positive, and it'll make a positive 28. Make the 1 negative, and that'll make a negative 1, which would subtract to make 27. So take those two factors and set them equal to 0. 7x minus 1 equals 0, and x plus 4 equals 0. So when I go ahead and solve, I'm going to end up adding the 1, so positive 1, divide by 7, so 1/7. Here I have to subtract the 4, so I get negative 4. Those are the two answers. Well, the next set of problems asks us to use completing the square. So there'll be two problems that you complete the square with, or maybe just on one of them you might just have to figure out what it is you have to add to both sides. Well, anyhow, and then one will be something with the completing the square to find the proof for the quadratic formula. So the first one here I would do is take half of the b term, so negative 4 times by 1/2, and that equals negative 2, and then square that number. Square that and you get 4, and that's what you end up having to add to both sides. See, that completes the square here and makes it an x minus 2 quantity squared. Whatever you get for half the b term goes inside the parentheses there, and this all equals 10. And so from there, the reason why we completed the square is so we could take a square root to cancel out the squared symbol. And so that leaves us with this x minus 2 is equal to plus or minus the square root of 10. So you just have one step of adding that 2 to both sides, and you get your answer there. So we'd have 2 plus or minus the square root of 10. That would be it. So we get to practice a few more of those. Negative 6, divide that in half. And so we end up with a negative 3, but then you got to take that negative 3 and square that number, and that's how we get 9. And so that's the number that you end up having to add to both sides, so plus 9 plus 9. And so we go ahead and get the factored form of this trinomial that's now a perfect square, x minus 3 quantity squared. Notice that the numbers need to add to make a negative, so that's why they have two. That's why it's a minus sign inside the parentheses there. And we go ahead and Add the 2 and the 9, we get 11. We can take the square root of both sides. That'll cancel out the squared symbol, leaving us with this x minus 3 equals plus or minus the square root of 11. Just one step there of adding 3 to both sides, so we end up with 3 plus or minus the square root of 11. Well, the next one, you want to take that 3 and take half of it, but when you take half of it, you end up with a fraction, and that makes 3 halves. And that's okay, just take that 3 halves and square it, and you end up with 9/4. And so that's the number that gets added to both sides. So 9/4 and 9/4. And then from that point, we need to go ahead and factor. And when we factor, it's going to factor to x minus, and then 3 halves. So this was 3 halves here. X, actually plus 3 halves, because they add to make positive 3. So 3 halves, quantity squared, equals, and then we need to come up with that common denominator, which is 4, so it's going to be 16/4 plus 9/4, which makes 25/4. And so we end up with a perfect square there. When I take that square root, I end up with taking the square root of a 5/2. So I end up with x plus 3/2 equals plus or minus 5 halves. Well, all you have to do there is subtract that 3/2 from both sides. So we'll subtract that, subtract it here, and we come up with 2 answers here. So we have 5 minus 3, which makes 2/2, which makes 1. That's one of the answers. The other one is going to be negative 5 minus 3, which makes negative 8/2, which equals negative 4. So negative 4 is one of the answers. 1 is the other answer. Well, the last problem here deals with completing the square, and we're solving for that quadratic formula. So they're going to just have the next step, or one of the steps that you have to do. So the first thing I would do is move that c term over. So subtract that from both sides, and then I'm going to divide each of the terms by a. And so when I do that, it ends up with this. We've got it, and let's see here, I got to put that x in here. So I got x squared plus b over a x equals negative c over a. And so from that point, we got to take half this b term and square it. So half the b term is going to end up being b over 2a. But I got to square that. So I end up with plus b squared over 4a squared. And so I end up adding that to both sides. B squared over 4a squared. And so when I go ahead and factor that, I end up getting half the b term. So b x plus b over 2a, and then that's being a quantity squared equals, and then we end up with a b squared. When I combine these two terms, I got to multiply this negative c over a by 4a, and I end up with a b squared minus 4ac all over 4a squared. And so I need to take the square root of both sides. Square root of this side, take the square root of this side. That'll cancel out the squared symbol, leaving me with this x plus b over 2a equals plus or minus the square root of that b squared minus 4ac all over 2a. Notice that the denominator's the same here, so all I have to do to solve this is do an opposite operation. I just have to subtract b over 2a from both sides. So subtract the b over 2a, and I can combine it as one fraction, and it's just the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the answer. Well, those are up through 39. There will be more problems in other parts.